Good morning, geologists. Today's topic is models, and this will be on page 27 in your science notebook. The objective for today is I can explain the importance of using models in science, identifying the types of models used. So today our notes will be in white on the left instead of red, and green will still be on the right. So be sure to write down all of the notes that you see listed in green. Model. A model can be an object, diagram, or computer program that represents something that a scientist is studying. Models enable the scientists to share their ideas and make predictions. So don't worry about any of that stuff you see in yellow. Just get down what's in green. Let's go over some types of models. One type of model is a physical model. Again, remember, the white is on the left and the green is on the right. A physical model can be a physical representation, such as a small version of a large object. And right here you see a small model house. That's something someone like an architect would use in a presentation. On the right you can see a globe, and a globe is a physical representation of the world that we live in. Another type of model is a two-dimensional model. And guys, you know this. You might have heard two-dimensional being called 2D. So a 2D or two-dimensional model can be a drawing or diagram of an object or a process. And here we have a subduction zone being shown in a 2D model. The last type of model we're going to talk about today is a computer model. And that's just what it sounds like. It's going to be an array of different types of representations made using a computer. So let's take a second and see an example of one. What I love about this model is it really helps me to understand the idea of seafloor spreading. I now understand what Miss Brady was talking about. The crust on the outside is getting pushed further and further, and that makes it older. The newer crust is right by the magma source. Now, I'm going to show you some examples of different types of models. We're going to talk about how a scientist might use them, and then you're going to tell me what kind of model this is. And remember, it could be a physical model, a 2D or two-dimensional model, or a computer model. So this model is something a scientist who studies ecosystems might use in understanding the relationships between different plants and animals. There's a key featured, it's a coral reef ecosystem, which is labeled, and then it even lists some major threats and management priorities. What type of model is this? Let's look at another model. A scientist who studies rivers may use a model like this to help them understand how rivers will flow, maybe depending on the slope of something and the geographical landscape. What type of model is this? Is it a physical model, a 2D model, or a computer model? I wonder what type of model this is. I really like that it's made out of connects. Scientists who study chemistry would make a model like this of atoms and molecules. So now tell me, what type of model is this? Physical, 2D, or computer? This one's really cool. It's my favorite model on the slideshow. Scientists who study weather might use models to predict how storms will travel. So we're going to show you a quick clip.
1 miles per hour. I mean, if you follow the cone here, you get a sense.
Let's get that guy out of there. So now you can see what this model looks like. It's showing a storm traveling up the United States coastline, and it's getting bigger, it looks like, as it goes up. You also see the different miles per hour that it is traveling, or speed of the storm. Tropical storm Bertha. So getting back to our question, what type of model was that? Was it physical? Was it 2D, or was it computer based? Wow, now it's time for some practice. Yes, I love practice.